One more video over chapter 6, just to introduce this concept of synthesis. So how do you make molecules? So for example, if we wanted, if we had cyclohexane and we wanted to make that molecule. So maybe we need this molecule for some reason. Maybe this is a pharmaceutical agent, for example, and you can't find it in nature, or if you could find it in nature, you can't find enough of it in nature. So you have to synthesize it yourself in lab. So, but maybe this is available. Of course, these are both very simple molecules. They would both be available, but let's pretend like they're not. So maybe this is not commercially available. But you need it for some reason. Whatever that reason is. So if you need it, but it's not available, then the only option you have is to make it yourself. And so that's what synthesis is to take something that is available and convert it through a sequence of reactions to something that you need that's not available. So this is where organic chemistry becomes very difficult because the only way to do synthesis is to know your reactions extremely well. So you just got to be able to pull reactions out of your head to know what reaction to do and what sequence to do those reactions in so that you can make what you want to make. So in this case, you could think about this working backwards. Well, what could I have made that from is one approach. So to do like a retrosynthetic analysis. Or maybe you can just see this in your head and you kind of know what to do working forwards. So at this point, we're very early in organic chemistry. You have not covered a whole lot of reactions, so there's not a lot of synthesis that you can do. So this is just a two-step synthesis using reactions that we've covered so far in chapter 4 and 5. So if you have an alkane and nothing attached to the alkane, the only reaction that we've looked at what you could do is you could attach a bromine or a chlorine to it. So if you took this and reacted it with Br2 and light or heat, for example, then you could have attached a bromine to there. And you could have made bromocyclohexane. And so once you have bromocyclohexane, then you can convert that to the alcohol. So you could react this with H2O, for example, and do an SN1 reaction. Or you could have took this and reacted it with something like potassium hydroxide and done an SN2. Right, so that's basically what synthesis is. So we have not covered a reaction that would convert. Let's call this A. That would convert A to B directly. So if there's no reaction that we know to go from A to B directly, then you had to go through a sequence of reactions, and that's synthesis. So we would make bromocyclohexane, and then we would purify it, and once it's purified, then we'd react it with water or potassium hydroxide to make the alcohol. And once we had the alcohol B, molecule B, then we would isolate that and purify it as well. So a two-step synthesis to do this transformation. Okay, so if we looked at another example, so what if we had that and wanted to make that alcohol? So we start with 2,3-dimethyl. Now let's do something different. Let's do this. At least something that you know how to name already. So 2,3-dimethyl butane. And you want to synthesize, let's see, 2-iodo, sorry, that's not 2,3-dimethyl. That is to 2-dimethyl. And you want to make 2-iodo-2,3-dimethyl butane. So how do you do that? So we have not covered a reaction that you could do that in one step, which means you have to go through a sequence of reactions. So, and this will be another just a, whoa. We have not covered enough chemistry yet for you to know how to do this. Let's see. So let's put this back to alcohol. And we won't worry about the name because we haven't looked at how to name alcohols yet. Okay, so how do we do that synthesis? So if you notice something in the synthesis, the carbon skeleton has been rearranged. And so that should clue you in to know that at some point you need to do an SN1 reaction, because that's the only reaction that we've looked at so far that undergoes rearrangement. So if you're going to do a rearrangement, you need an alkyl halide. That's what we've looked at so far. So if we took this and reacted with CO2 and light, for example, so where's that going to put a chlorine at? So we got 6 carbons, and it's going to go to carbon 2, right? Because that's the most stable place to put a free radical. So if you did this reaction, that would put a chlorine there. And now if you reacted this with water, not hydroxide, right? Because if you did hydroxide, this would do an SN2. And there is no rearrangement in an SN2, so the OH would just replace the chlorine and you're done, and that doesn't make what you wanted to make. But if you reacted it with water, it would do an SN1, and that would make this carbocation, which would undergo a 1,2 methyl shift. And then water would attack there, and then you would lose a hydrogen and then subsequent step, and that would give you the product that you wanted. So that would be a 2-step synthesis. So basically, you would take this CO2 and light or heat, or Br2 light or heat, doesn't matter, and H2O, and that would make that molecule, right? Through this sequence of reactions. Okay, so that's basically organic synthesis, and this is by far one of the hardest parts of organic chemistry for students, because the more reactions we cover, the more synthesis you can do, and the more steps you can have in your synthesis. So for example, when we cover chapter 8, we cover like 20 reactions in that chapter. And then the synthesis possibilities that you can do becomes much, much more complex. And so the only way to do synthesis is to learn your reactions extremely well so that you remember all of your reactions and you can pull out the reactions that you need and then string them together in sequence to accomplish the transformation that you want to accomplish. Okay.